basic function of a vacuum cleaner is pretty straightforward. A motor whizzes round, an impeller creates a partial vacuum which sucks the dust into a vacuum bag. The Miele C3 cat and dog, from which these parts have come from, is pretty much the same, and there have been lots of videos on YouTube to help people understand how to take the thing apart. But what I've not seen to date is one that explains the root of the power and the circuit diagram, and if you like, not at the component level, but certainly at the PC level of what's going on. So in this case you have a motor, and here we have a unit plugged into the motor, which is inside there is a triac, and the triac is being triggered by the printed circuit board output voltage. I'll come back to that. So what you have here is the blue line, the neutral line, that is the same all the way from the main socket and is not switched on and off by the on-off switch on the device, but is actually live the whole time. So the blue line provides a continuous flow to the motor. The black is the one that gets switched on and off by the on-off switch at the top of the vacuum, but that doesn't actually get the motor running. The bit that makes the motor run is the trigger, the brown, bit misnamed or mislabeled in my view, because normally you go for blue and then brown, blue for neutral and brown for live, and then you'd use the black as the trigger, but that's not the case in the Miele. So what you have is the mains coming in, blue line goes all the way through and is looped, and also goes to the PCB, printed circuit board, which provides the trigger circuit, which I'll come back to, and then is just looped on onto the onto the motor. The black is also straight through, but the only thing that it's being controlled by or turned on and off is by the switch. But both blue and brown, blue and black go to the PCB. I've got another one here which actually will show you on the top side. There it is, and that's where the connector block is connected in to provide supply, and then the trigger out on the brown goes through and then ends up on the gate of the triac. So when we take one of these devices apart, the first inclination is to see if the triac is working and the thermal fuse, which is both housed inside the block that you see here. The point being that you have to take the front off the motor. It's reverse thread, and it's worth noting that there's some markers. They were out of place in this case, and I think where I read somewhere that they're meant to be aligned up, so I've put it back together again so that they are aligned. I don't think it hurts if I'm wrong. And also I put markers to remind me where the front panel is. There's loads of other videos that tell you all about that. But essentially inside the motor is the thermal fuse, cut-out fuse, and the triac. Well, once you've convinced yourself that both of those are okay, and I did in this case, by taking it apart and having a look at the triac, and it presented the right passive volts correctly, and then the brown line, as I said, provides the trigger circuit coming off of the PCB. It was pretty clear that the trigger circuit was not being generated on the PCB. So therefore, instead of doing it in this case, instead of going through and finding out whether it was the resistor or the capacitors, I found a cheap board to replace it. In fact, it's an upgraded board, and it was almost as cheap as actually getting the normal culprits of maybe a capacitor or a resistor. But if it was anything else, I wasn't in the position to actually do such a job anymore. But essentially the signal flow therefore is power to the motor is available all the time, but the triac, which is triggered and chopped to give it different speed of running, is provided by this little board.